Do you hear me? So we talk about model render. So just to illustrate, focused on map rendering, so that's why there is a map, and also Rlin, it's a fast fish, and it has three species, so it was to stay in the same ID. So, thank you everybody to be here. After the talk, I try to summarize and give you some hints and some things. So just to start the context, Java 2D is a great API. It's quite old, but it's great. It performs quite expanded. For the moment, you have two anti-aliasing renderers. What is utilizing renderers? It's mainly to perform the draw and fill operation in shape. It's not about text renderers. And you have so Ductus, which is the closed source renderer. And you also have SOPC since Openjdk 6. And the status in 2013, Ductus is very fast in a single thread context, but it does not really scale. It means that you have a web server, you are doing rendering in parallel, it's mostly lagging or there is some bottlenecks. PCs is mainly slower because it's a pure Java renderer, but that's not the point. It's mainly a different approach, but it scales better. If you have several threads in parallel, it becomes faster than Ductus. In the context, there is no current GPU solution. The Java 2D pipelines use the GPU to perform some operation like images, pixel blending, and so on. And here also you have JavaFX, it's an anonymous code, it's client application, it uses over renderers. It's OpenPC, it uses also native things. So why the Rlin renderer? It's mainly OpenJDK PC fork. So I started in 2013. Mainly working on client application in my astrophysics laboratory, and I made some profiling of my application with Openjdk, and I see it was allocating a lot of memory, it was a bit slow. So I started providing patches to improve a bit that, and so I subscribed to the mailing list, I sent some patches which were optimizing, and some incorrect feedbacks. But we decided with Rlin, which is in the GeoServer team, to go on and put this effort on GitHub. So the Rlin renderer and also the mapping projects were available in 2014. Openjdk, Mapping is a tool to serialize graphics operation, like map rendering, and then you can replay it. So it's very powerful to me, because it helped me to diagnose, to repeat the text, and you will see later. So here are the links to the tools. I have several branches on Rlin renderer, so yeah, you have the pointers. So the objective, be faster, possibly improve the quality, the rendering, the visual quality, and it's stay compatible with Oracle, Openjdk, 7, 8, 9, any version. It was a very big personal effort. We made several releases in 2014. And as I said, it was test-driven development. So with the regression tool, I made a map display which compares the outputs between renderers to stay compatible pixel by pixel. Also, performance, a lot of runs of benchmarks and profiling. Moreover, this release have a small exposure in the GIS community. Mainly the GeoServer from Rlin made a lot of benchmarks, and the GBC provides some use case and testing. It was very great in feedback. Here it's a screenshot of GBSig. It's a desktop SIG application, and here you see it's 100 million points, which are rendered in a few seconds. It's a large point cloud, and then you can see some tubes in the sea. And so it's parallel rendering. And here it's a fun blog post from Unreal in the first Rlin release 0.3. And here you can see that Victus is in blue, so it's quite fast. But this is a bit slower. But Rlin sometimes at different scales, it's very different. It's another scale in performance. I made a lot of benchmarks. You can see on the wiki page of the project. So next, how to go back into Openjdk. We signed, both of you, me and Unreal, we signed the Oracle contributor agreement. We stay compatible with the same license, and we have the aim to go back in Openjdk for everybody. And so we discussed a lot, thanks to last year at FOSDEM, we discussed together how to bring it back. And so since March, I've been integrated in the graphics rasterizer project, mainly working with Jim Graham and Phil Weiss. I work hard because it was not so easy to provide reviews, patches, and going slowly, but certainly. In July, we proposed the JET 2265, and Marlin graphics was accepted, targeted, and completed in the CMD. It's integrated since Openjdk build 96, and it made also Marlin even faster. I made release also on my GitHub, being in sync between the different code base. But it improved a bit the quality, the coordinate bonding, and also the large pixel chunk were improved. And we will see later. So my feedback on contributing to the Openjdk, it was very interesting. I've learned a lot of things. I discussed with many people, and there were several issues. It's not easy for an outsider because my company is research. It's public research in France that totally nothing to do with Java or any of the companies who are here. So, first, the licensing issue, it was not third-party code in my contribution, so I have to make some clean up. The web process, it's great, but it's a bit heavy, and for newcomer, you have to learn how to create them. There's a lot of tools, and you have to push them on the Openjdk servers. You have to get an account, you have to get some credentials and rights. I got a lot of discussions by mail, and it was quite typically more than 1 month per patch. It was a very big patch. It takes a long time, and the time zone difference is not easy. It has delays and cannot really Skype with people. So let's go faster. So there was not a lot of documentation, there was no continuous integration, easily accessible for outsiders, and let's go faster. So how it works Java 2D, 3 words. You have the Sun Graphics 2D, which delegates to the AS-shaped pipe to render the path. It has to compute the coverage mask, and then you have the mask field operation regarding software like C-Code or OpenGL, which blends the pixel on the screen or in the image. Marlin, really quickly, like PCs, you have to provide the coverage mask, so you have several steps. We have a pipeline with the dasher, the stroker, the renderer. We go forward. Typically, it's a quite well-known ActiveHTable algorithm. Yeah, it's quite tricky because you don't have pointers in Java, but you can do some integer-based pointer. You have some integer, the integer serves like a pointer in an array, and then you have some structs, and it's really close to value types, something like that. Every data is not allocated in the heap, it's all flattened in the arrays. just an illustration. So Rlin performance optimization is mainly to avoid the GC allocation. In Rlin, you don't need it at all because I use a small context which is kept in memory attached using a web source reference, kept in thread local, and so you always reuse the same small chunk of memory, which is quite optimized. And it's more like C programming, you use only those parts to be as fast as possible. It's really tricky, but I've added a lot of checks and things inside Rlin, so I can ensure it's correct and efficient. I use, as I said, some different optimization and profiling tools, and also my metrics and internal checks. The map benchmarks is just because I will give you some plots, just to say, to reduce the variability, I have to disable cross threading, I have to use fixed frequency to ensure the scalability, and always have the same initial conditions. So before Rlin, in blue you have ductus, in red you have pieces. So you can see that typically ductus is a lot faster than pieces, but when you have 4 threads, 1, 2, 4 threads, pieces becomes faster. And then here is Rlin. You don't see it, it's normal. It's always here. Here it's a very complex map, and so it's really fast. Here you have the ratio. 100% it's Rlin, so you see the others are slower. And then it's just a small issue with volatile image. If I use buffered image, totally perfect. If I use volatile image, you see the same effect. At one thread, sometimes it's faster, sometimes no, but you see there is also a bottleneck with volatile images. Volatile images, it's images who are staying in the GPU memory, and you can use a faster blending using the Openjdk and things like that. So how to use Rlin, just a few points here. You have to add, if you download Rlin on my GitHub, you have to add this line. If you use Openjdk name, now it's really easy. It works also in Jigsaw. And here is the demo. So let's start it. So the demo, it's really straightforward. It's the same tool I've made, so it replaces some serialized drawings in some map. And you see here it's pieces, typically 20 frames on this thing. It uses 4 threads in parallel, 4 different images which are regularly painted. So you see that it's not stuck, it's quite slow, it depends on the size. Maybe I'm late, so I will go. Yes. So you see the almost speed. So there is just an illustration with maps. So there is a step where it calibrates, and then there's 1 thread, then 2 threads, then 4. That's why you see the thing. And it just made a rotation because it's just to see it visually. So here the map, you see almost 6 frames per second. And then with Rlin, so it calibrates, and then you see that as it's Java, you see the code is compiling and optimizing and going a bit faster. And then you have 16 frames per second on this one. It's going very more fast. And here, as the image is smaller, you have less pixels to blend, so it goes even faster. And so ductus, I want to show it because it's really interesting. Yeah, it's the frame per second I've made with what I will show you. So ductus is quite fast. Rlin, 90, Yes, here it's species, and it depends. When you add threads, it goes faster. Now there are several tuning parameters. Typically, you can adjust the number of the subpixels. So if you want to go faster, you can simplify the quality, or you can increase it. You can also adjust a bit the tile size. It could be interesting for different pipelines on the X-renderer or things like that. And also you can handle log statistics. Here it's a summary of the few settings. And also, I would like to do some work as the cut freeze of GDK9 is not reached. I would expect to do some new improvements. And of course, I would be very pleased to get some feedbacks, and please try it with your use case or your context. You can try parallel rendering. And if you would like, I would really enjoy if you could help me or contribute on your algorithm. Some quality ideas. For me, the most important one is the gamma correction. You have gamma correction on the text rendering, but on shapes, it's not the case. And it's really, really important. It's mainly done in C macro in the Openjdk, so I'm not really good at that. But I could try to, I've done it in Java, but it's not a good idea. And then also the algorithm should be improved to use some analytical pixel coverage to be more accurate in the path. This is mainly the two ideas, and it's on the performance. There is no clipping algorithm, and even it's not so straightforward to do. And also we could improve the cap and join processing, simplify a bit the segments and the preliminarity and things like that. But for me, the two main important things is the gamma correction and the more accurate algorithm to compute the coverage of the pixel. It's a bit illustrated that you can use typically the area, the trapezoid area, instead of counting subpixels. So that's all, folks. Thank you for your attention. I think I presented an overview. If you have questions, contact me, ask your question. We're really happy to discuss with you. Any question? Yes? Sorry?
How fast do you think you can go? How much faster? Do you think for some value types in 10
yes. Yes, value types could be helpful, because we did it manually here, but I think it can be improved. And safe is a bit helpful also to avoid bone checks, but the value types could be a bit faster. But it's software rendering, so it's not comparable to a GPU-based solution. Value types, yes, it could simplify the code, and maybe avoid bone checks. Because there is a lot of rules, a lot of tricks in the code. It's quite tricky. Yes, please? Which would discuss that. I know that OpenPC is in JavaFX. Maybe we could try to. It is, I think, the PC's code has been ported to C. So the same approach could be done. It's a bit different because the stroker or the property of the render are a bit different. It should be adjusted, but it could be ported, of course. Because I spent a lot of evenings time on home evenings, and so that's why I'm really like to get some developers involved, to have people in there who is interested. I have a question. Yes, as been mentioned, for the moment it's the default rendering engine in both Openjdk and Rlin. I think Jim Graham proposed that in order to make Rlin the maximum exposure, and I hope it will stay the case. But in case there was an issue, I cannot guarantee that we will stay in the Openjdk. Will be very pleased if it is the case. So, thank you.